So, okay, yeah, that's the guy. That's Burak. He is vice president of cloud computing in Fiserv, 20,000 people company, and he's running the internal cloud operation. Very knowledgeable on that side. On my side, I'm more the HPC guy. So, and I already told before that it was based on a bet where he came in and said, Wolfgang, we in enterprise cloud computing, we are moving very fast. Look at these numbers. Why are you guys so slow in HPC? Yeah. And so I said, I mean, there's a big difference. You don't have challenges, we have challenges. So we bet that someone can prove that. And we thought to collect 5 teams who throw some HPC applications onto a remote resource and study this end-to-end process. And in a sudden, when we did a little call for participation, we had 160 organizations. And we had to build 25 teams. And that was in round 1. And we are now basically at the end of round 2. And already now preparing next week. So I go over to Los Altos, where this guy is living, and prepare round 3. So, okay, let's move fast because of the boat. It is UberCloud. It's a crazy name, I mean, you know. But it is UberCloud because it is sitting on top of all these different clouds and selecting the best cloud or the best remote resource for the incoming end user, one after the other. We look, we scan, we have a drive database, and so then we match. This is done by hand, intentionally, we said. We don't automate this. Currently, we are developing an automation algorithm for the whole thing, which is based on what we call in mathematics the Hungarian wedding algorithm, matching. But we do it intentionally by hand to really study this 22-step end-to-end process, getting the end user's application onto the remote resource and getting the results back, so that we can really figure out where do they struggle, where do they stop, where do they even really fail. So, okay. So that's why we call it UberCloud, and it is basically paving the way to HPC as a service. Okay, so let's start with the market. So the market, there are only very few surveys in HPC in the cloud these days, and one of them is done by Inside Pharma. They did a report in 2012 about biotech pharma using HPC. This is one of the very early, very concrete reports where they try to answer questions like which cloud-based platforms is your organization using? What do you envision your company's biggest concerns to be, blah, blah. Do you feel that current vendors offer the solutions that you need, or do you need different solutions? What proportion of your IT spending is devoted to cloud? Very basic questions. And we know in biotech, pharma, they have a lot of, molecular dynamics and other great applications which use a lot of HPC. So here, 2 results for our motivation today. So one is the usage in pharma a couple of months ago. So indeed, there are a couple of guys using it in a hybrid way. 7%, even 7 others are using, like Amazon, public cloud. You see on the Amazon application list, you see quite a few bio companies. So on-premise, private clouds, 15, so they are moving forward very carefully. They have applications which have to stay inside for very good reasons, and some they can throw out. And currently evaluating these solutions, 17%, but so far not currently using any cloud-based solution, 52%. And this piece of cake here has been very different a year before that. So that one was much bigger. And you see the dynamics when you compare these figures. Yeah? So there is movement in the whole thing. And the second big question is, how would you describe the interface among the different cloud-based platforms that you currently use? So basically, how easy it is to get to the cloud. So that's the question. And interesting enough, is only 11% that, yeah, it's very smooth, flexible, and fast. So it's good, but need customization. You know, these are all these guys here, these are the early adopters. And usually the early adopters are very often very optimistic. That's why they move forward. Yeah, we can handle that, we will do that, we need that, etc. So that's why I think this is a little bit, optimistic. Significant effort, 26, and inflexible, 14.9. I can imagine these guys here have worked together with consulting companies who are successively also moving into cloud consulting, helping companies to get onto the cloud and back. You know, there are these companies like Bioteam and others, especially in this space here, who have developed even very nice infrastructures, cycle computing and others as well. Yeah. So, okay. So, what we thought when you see this result, so that's the previous result, which says, no, we are not using, or we are evaluating, and the others say basically only a very small percentage says, yeah, it's okay, we do that. Often enough with additional support from someone outside, and the others are still struggling with getting on the resources and so on. So, two very good reasons why we believe, and we see the proof, because the experiment is exploding almost, so it's accelerating, say. We hoped for 50, we got 160 in the first shot. We are now approaching 400 organizations who have joined this experiment within 7 months. Okay, so let's move on. We call this UberCloud experiment an open humanitarian collaborative community effort. And it's really, you know, by outsourcing a couple of good things, we see crowdsourcing. Everybody is helping everybody else. And in a very nice, I mean, this is a great atmosphere on that platform. So the objective is making available HPC as a service for everybody on demand at your fingertip. So in detail, for SMEs and their engineering applications, you know, this is mostly currently, at least the focus, digital manufacturing. So whenever there is a product at the end and there is R&D at the beginning, that's what we look at. Yeah? To explore the end-to-end process, really in 22 individual steps, which we have boiled down. You follow a base camp, which is a management platform, a project management platform. You follow these 22 steps. When you click on step 7, then a box opens and it says you should do that and that and that and that now. After you're done, you click on it, and then it disappears. Box 8 opens and you go to the next step. Of using remote computing resources, we included also big supercomputer centers, like San Diego, for example. We have about 16 supercomputer centers and almost 20 HPC cloud providers being part of that. As a service on demand at your fingertip, that's a dream. Everybody is hoping along the experiment that we'll get there. Currently, it is really working. And learning how to resolve the many roadblocks. I mean, now with 60 teams up and running, you can imagine in every team facing 2 or 3 roadblocks on their way. We get a lot of insight, and also in how they solve it, how they solve these or resolve these roadblocks. So why this experiment? So foster the use of HPC in digital manufacturing. There are just 360,000 SMEs in the US in digital manufacturing alone. So that's a number which has been published, so that's why we know about that, and we use it here. Using remote resources, I mentioned that one. support initiatives from Intel, NCMS, the National Center for Manufacturing Sciences, and many other organizations to uncover this missing middle. We don't do that. We don't take care of manufacturers who have no clue about what HPC is, even HPC on the workstation. So that's, even Intel goes even farther back. They are looking at those manufacturers who do just physical prototyping. And they want to get them on the HPC boat for very good reasons. Yeah? Next is observation. That's what I told you. Business clouds are widely accepted, but our clouds, so to speak, our cloud computing is not, for the good reasons that in business clouds, there are already a lot of standards. There's web services on one side, a web server with the application, and you do a query, and then you get easily an answer back. On the other side, HPC, you know exactly what you have to do. I mean, you have to throw a big application onto the remote resource, which very often is your holy grail, is your most important asset. So you lose control over that. There comes trust in the game, and quite a few other things. So barriers today, just to summarize, I don't have the time. Just 2 days ago, there appeared, I hope, a nice article in Bio-IT World, the feature of the week, so to speak. It was when you received their newsletters, in the newsletter. And this was unique because the first time we really elaborated on about 3 pages or so on about the 10 most important and most severe roadblocks and how teams solved them. So it's in that article. Just a summary: complexity, IB data, around shared software, licensing, performance, because of virtualization very often, specific system requirements, which don't often fit to what the application requires, which comes in new, freshly, data security, interoperability. We see end users struggle with one provider, and then they think, okay, let's move the whole thing, which we have done over the last 2 months, now to another one, yeah? To get an easier thing. That very often does not work. Yeah? So because they are not compatible, there are no standards and so on in this area so far. So the benefits of being part of that, especially for the end users who face this very new tsunami coming over them, is it's free, on-demand access to hardware, software, and expertise. These are the most important ingredients for an end user to get on. Hardware, the software should be there, or installed, or thrown over, and the expertise, you need to do that. With one-stop resource shopping experience. So they don't have to go around, they get everything out of the experiment database. No hunting for resources in the complex emerging cloud market. Which is the best cloud for my application? Which is the best service, the best support, the best expertise for my application? And there are about, I would say, in our HPC cloud space, in the meantime, 250 or so. Hi, James. In the market. So how do you know which one is the best? So we do the first job to do that. In the future, this will be more automatic, so that you can be assured that you get the best most resource and the best most expertise supporting your team for the time when you take the application and move them over. And professional matchmaking, I told that, perfectly tuned to end-to-end process, lowering the barriers for a couple of good reasons, leading to increased competitiveness. So that's the final benefit when they really decide to include this into their HPC strategy. When they can, burst into the cloud whenever they need it at their fingertip. They increase their competitiveness, their business agility, and the innovation they can create with that. It's crowdsourcing, I mentioned that, and no one is really getting left behind who jumps on that. So you are part of this new wave and can benefit from this growing community. So the advantages, I basically mentioned the whole thing. I can skip that for time purposes. So where are we now? Very quickly, we are almost at the end of round 2 Round 2 was with about 350 participants until, I would say, about 2 weeks ago, before we started another big PR activity to invite new participants. So we are now, as I said, approaching 400 organizations, mostly companies. Oh, that was fast. The experiment reaches to every corner of the globe. We say there are participants now from 31 countries, almost in every corner of the globe. You can register. And you see what we have done. We started with hpcexperiment.com, supported by Tarbor Communications. And then we saw we just got one industry end user. So obviously no industry end user is reading HPC Wire, which Tom didn't like too much. So you certainly have better results, I'm sure. Yeah, and okay, so that's why we came up with the idea, let's try to speak the language of the end user. So we rephrased everything which we have done, published here, into CFD, CAE, finite element, and so on. A very simple trick. In a sudden, it worked nicely. Yeah? So in a sudden, I mean, we got up to, we got 25 real nice end users, industry. And you see what we just did, comp bio, and we got 15. And it's still very cumbersome, because, I mean, it means a lot. It's not the day job. They have a day job already. So it is almost a night job when they join that and do that. So now we are with 60 teams. I have to accelerate a little bit. So round 3. We have a webinar next Tuesday, which we do from California into the world, 8 Pacific time, 8 o'clock in the morning. If you want to join, send me just a little email. We have 1 hour, which is half an hour. So 15 minutes, us presenting statistics, update, blah, blah. Then we have 2 teams reporting their experience and their use case. And then we have another 20 minutes or so Q&As. So we already now, Burak just wrote me an email before we have 64 registrations until now, and I will certainly get to 80, 90 or so. Because it's Pacific time, 8 o'clock in the morning. So 4 around the world. Okay, so some statistics very quickly, 160 participants, 36 end users. So that was round 2. Today, that is not true anymore. I mean, it changes permanently, obviously. So the status of round 1, which was the previous one, interesting. 15 successfully completed, teams completing in time. They are all in the 74-page final report of round 1, which appeared in December. As use cases, 2 to 4 pages use case, different engineering applications, reporting according to a given structure their experience. 1 monitoring application, start first job, 3 setting up, and 5 stalled, meaning they failed for very good reasons. We especially analyzed these guys. Well, why are they so slow? Why are they stalling? That is very important. That gives us real insight. Not really why they were successful. Yeah, I mean, they made it. Still, they overcame tons of roadblocks as well. And so that is old, but just to impress you, that's that one. And about half of our participants, especially the end users, interesting enough, they want to stay anonymous because for competitive reasons. They don't want their competitor to see that they are starting looking into that. So that's why. So we have, I mean, as you see, I was very impressed, basically, still be impressed about this list. I mean, ANSYS, Simulia, CD Adapco, these are the remote visualization guys. There's another ESI here, and so on. So big guys, among others. Same for the experts. I mean, you see quite a few you already know, but you also see some which you don't know, because, you know, they are of the size of 20, 30, 40 consultants. But they do, mostly, these guys especially, do a very good job. One example is BioTeam, for example. So next one, building the teams. Okay, so after that I almost shut down here. So what's the time?
14.
Huh?
14. We're good.
14?
No, 4. Oh, sorry. We're good. We're good.
Okay. No, that's fine. So, yeah, I mean, I hate to be, the one who helps you to miss the boat. Basically proving this very nice flying word, oh, we missed the boat. I love it. Okay, so how does it work? An industry end user comes in, and immediately Borak or myself, we fight over because of this great application. Then we look at the software provider. The software provider is the single most important ingredient next to the end user, because the end user and the software provider usually are married until death. So is this end user in our database? Yes, he is, because he registered. Is this ISV in the database? If it is, where is this software installed? So we select maybe the 5 resources where this is installed. This and that resource provider, they are currently busy. So we cannot touch them, overload them with another experiment. So we select one of those which seems to fit best and which has time, which has, for example, no team currently. So after that, we look at all these requirements, and then we go into the database of the HPC experts. So which HPC expert, according to a couple of criteria and keywords, fits the best? We might get 12 answers. And then the same criteria hold which one is busy, and where is the best suited one, and so on. So it takes very often up to a day to build such a team, because we call back, we want to know more, we want to be very careful. In the first round, we made the experience, if we don't do this very carefully and thoroughly, then this already might be a reason for failure soon after. So, okay, like that one here on the right side. End user. So I explained all that. We want to run. After that, the team is ready to go. So these are the successful teams in round 1. And you see some very nice applications. Anchor Bolt. This is Simpson Tie, by the way, in California. Building building parts for houses, resonance, radio frequency, liquid gas, ship hull, dosimetry in bio, car acoustics, even something like side impact gas bubbles, and so on. So, okay. And they are all in the final report, which came out in December. So the actual teams, which we are still working with, and these are only now the ongoing successful ones. About 8 or 9 teams already died, and we analyzed why. So why did they stop? We want to be very careful to not frustrate them. We said, okay, go over to round 3, and we have learned why, and now we try to avoid this the next time, whatever happened. So, and you see there are already some bio things in there. The stent thing, which helps to widen arteries. These mechanical pipes things, and okay, and a lot of even drifting snow in urban, etc., from the rooftops. Very funny and very great applications. Flow around bicycle, including the rider, including the helmet, and these kind of things. So next one. Okay, so I have to skip that, but because of time. But very quickly, heavy-duty abacus structural analysis in the cloud. This is Frank Ding. He is from Simpson Tie, supported by Simulia, supported by Nimbix as a platform, supported by Sharan Kalvani from Intel, who is certainly familiar for some of you. Application, this is the Anchorage tensile capacity, steel and wood connector load capacity. Okay, so that's the use case. Again, it's written down nicely in the final report. Team 41, HPC Cloud Workflow, I skip that, challenges, and so on. So that's basically the result which they got. They faced, among others, a huge roadblock because they created almost 0.5 terabyte of data. You know, Abacus and other codes are like that. And they decided to do the evaluation and the visualization in the cloud. So they used one of the remote viz tools. Other groups now are using DCV from NICE for that. So we have three of the tools in the meantime. The nice thing is, you know, the more this community grows, the more you have a choice. It's really very useful. Okay, what we learned, and here are some of these. By the way, are these slides available in the near future on some website? Are they? They are? Okay, great. So then we can run over a couple of those. But I'm almost done. So bumps on the road, time delays. That was frustrating. In August, almost nobody joined. We started end of July, and we're of big hope. And then vacation came over us. So these kinds, you know, also in a team, people are going to conferences, going on vacation, and you know, always one team member is missing. So you have easily a delay of 3-4 days. Yeah? You have to cope with that. The nice thing is there is no time pressure behind. You know, there is no deadline, etc., because it is a 3-month experiment. And if you don't, or if you run over these 3 months, nobody cares. You can go over into the next round. Yeah, so we really try hard to relax any kind of artificial roadblock as possible. Time delay, no standards, as I said. Every team is facing different platform, different resources, different processes, getting back and forth, and so on. Authentication, authorization, bureaucracy, and you name it. Yeah. Okay, then everything is hands-on with most of the resource providers. So it takes really 1, 2, 3 weeks to get on the resources these days, except there are a few exceptions. There are already a handful of real excellent resource providers, Amazon not included. Yeah? So where you really go almost with a fingertip on these resources and into your application code. Hands-on, lack of automation, participants spend only small. Yeah, it's not their day job. Very important. Yeah? If people don't have time, they don't have time. Yeah? Right in the middle of team projects, we get a message, hey, we have to wait for 4 weeks. I got a big thing from my boss on the table. Yeah? Okay, so that's real life. And then, yeah, another reason why this is not their day job. So hurdles, reaching out to the industry end user is really tough. And if you talk to other experts, like to Intel's great effort to get to the missing middle, I mean, they face the very same or very similar challenges. They have even more difficult because the missing middle, as I said, is much more difficult to approach than, for example, all these workstation guys, the 20 million workstation guys in the world. Okay, so half of our participants want to remain anonymous. I said that for good reasons. HPC is complex, very complex. You really see that when an end user who is used to doing an engineering application code and ISV code on his workstation now has to move over into the cloud. Then matching participants is critical to a team's success, the matching part, to find the right expertise, resources, software, etc. And then these resource providers often have internal policies, legal hurdles even, licensing. You cannot easily, you know, as a supercomputer center with a Red Hat enterprise license on your system with a license, with an academic license, they cannot easily run an industry code. This is basically explicitly forbidden to do commercial things with that. So, by the way, we arranged an agreement with Red Hat that they agree for the experiment, whatever you do, guys, for the experiment, you can have our Red Hat Enterprise version for free. As long as you don't charge for these runs, because then it would become commercial. Barriers, same as before, we had that. So planning round 3, starting in April, not sure exactly when, maybe mid of April. We need a lot of cleaning currently. Expecting 500 organizations, ready for 40 more teams. So we already see the 100 teams at the horizon. More professional, more automation, more user-friendly. We are working on that. Extending applications towards life science and big data. We already have MapR, CloudSoft, and a few others now. And better guidance, 25 end-to-end steps, and better Basecamp team rooms for collaboration. So you have your own team room with your bookshelf, your virtual one, and with your discussion forum, etc. And especially with your 25 steps, to-dos, to move forward through the whole thing. Growing, what I didn't mention, we now, just 1 month ago, we started the UberCloud Exhibit. This is your one-stop service catalog. It is really like an interactive exhibition. So the end users, which means this time this is open for everybody, for the whole community, comes in, does some keywording, gets a bunch of recommendations, and so it's like a real exhibition. You move to the booth, you contact the guy, you grab information, you contact interactively, you talk to the guy, you get a demo, you do an experiment. So successively you get closer and closer together. And with what we get from there, it's $1,000 for 6 months. We throw it onto other PR activities to make it really popular among the community. 3 level support, that's most important, hand-holding and taking care. And okay, interesting, this one introducing the first commercial brokerage service. If one guy, one end user, has done an experiment and she feels happy and says, now I want to do a production. So for that first production job, we already negotiated with the service providers a 50% discount. So again, here we want to do a slow step into the real professional commercial environment. So why would you want to join? I don't know, but here are some good reasons. It is definitely the next big thing. It is coming over us. I mean, we see the response of only this experiment. So people are very curious, and it's, there is an occasion. Otherwise, I mean, they would have sit down and wait and look and see. But now they can be involved actively in getting their hands on it for a couple of months. So HPC is, get back. Yeah, that's HPC is complex. Low entry barrier to HPC as a service through an experiment. It's not even a beta. It is an experiment. Nothing can fail. Even a failure, a so-called failure in experiment, is a result. You analyze why, and then you take the guy to the next round and say, okay, now fresh start. Learning by doing, crowdsourcing, basically. No risk, no failure. Becoming an active part of this growing community. I mean, you never get away after that. You are part of that. We are currently building a crowdsourcing platform for that with additional bells and whistles, and learning how this fits into your research, into your business in the near future. So, okay. So that was the supercomputing show. You remember the Star Trek booth at Intel? This was a great thing. And we were there, so Intel invited us, and we got a great feeling to sit on these bridge chairs. So that's it, and I would really like to thank you, and wish you a pleasant evening. If you have questions.